Hello everyone, welcome to SCI-EASE. In this video, I'm going to take a very important topic of chapter 2 of 11 chemistry, that is Hund's rule of maximum multiplicity. In continuation to Aufbau principle and Pauli exclusion principle, Hund's rule that is very important for filling of the electrons in the orbital. Here, we will talk about the subshells like P, D and F, where in P there are 3 orbitals, in D 5 orbitals and in F 7 orbitals. So in these subshells, the orbitals which are present, they have the same energy. So there is one term that the subshells like P, D or F which have 3, 5 or 7 orbital respectively, they have same energy, they are known as degenerate orbitals. So the term here is degenerate orbitals. Orbitals having same energy. So how the filling of these orbitals in respective subshell takes place, that is given by Hund's rule. So what is the definition of Hund's rule? You should know the definitions of all these 3 rules or principle, because sometimes the question define Aufbau, Pauli exclusion principle, Hund's rule, and then some small numerical that can be asked in 5-mark question in your half-yearlies or so. So what Hund's rule states? It states that pairing of electrons, this line is very important, pairing of electrons in the orbital belonging to same subshell which I have told you P, D or F, it does not take place until each orbital belonging to that subshell has 1 electron each. That is, it is singly occupied. Okay? So this is each and every word. It's important to know how the filling of the orbitals takes place in different subshells. When we take the case of hydrogen, it has only 1 electron, so that will be filled here, okay, in 1s. When we take the case of helium, then its atomic number is 2, so this first 1s subshell that will be completely filled. Now take the case of lithium. What will be the result? It has atomic number 3 in 1s, and this is 2s, suppose. Here 1 electron that will go in 2s. Take the case of beryllium. It has 4. So what will be the result? 2s that will be filled, fully filled. Now comes to the case of p orbital, that is carbon. Okay. Then next is boron. Okay, boron. So what will be the result? Here 1s will be filled, 2s, and then the next electron that will go in the p subshell and first orbital. It can go here, here or here, because all 3 orbitals px, py and pz, they have equal energy. That is, they are degenerate orbitals. Okay. Now come to the case of carbon 6. So where this electron? First, you will write that the pairing 1 and 2nd. No, this is wrong. So according to Hund's rule, first all the orbitals, they will be singly occupied. So this is the configuration for carbon. Come to nitrogen. Core is same. Then it is half filled. This is a stable structure. Then come to oxygen. Oxygen. How many electrons here? 8. It has atomic number 8. So this is 1s, 2s, 2p. Where this electron that will go? Now the pairing that will start. Because all the orbitals of p subshell, they are singly occupied. Now the pairing will start. Now come to the case of fluorine 9. Then the second core that is same, you can draw on your own. Here, what will be the result? This and this. And next is neon, fully filled p orbital. I will draw only the p orbital. What will be the result? It is the inert gas, fully filled p orbital. Okay. And when in case of the d orbital, what is the case? Just I will tell you that if it is d4, how you will fill this d orbital? D subshell. There are 5 orbitals. 1, 2, 3, 4. Is it correct? No, this is wrong. First, all the orbitals of d subshell, they will be singly occupied. And when it is d6, what will be the result? Then the pairing that will start. 1, 2, 3, 4, 5, and then 6. And in the case of f orbital, how many? In case of f subshell, there are 7 orbitals. I'm drawing with different pens, different colors. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, if it is F8, then how you will fill? 1, 2, 3, 4, 5, 6, 7, and now the pairing that will start. Okay, so half-filled, no doubt, half-filled orbital, that is, and fully filled orbital, that fully filled subshell, you can say, that is the most stable configuration that we will study. In the next video, I will tell you the electronic configuration of many more these elements. I have told you up to neon, and then after neon, we will start with this, and we will apply all the 3 rules there. Okay, we will write the electronic configuration by of-Bohr principle and then fill the electrons by Pauli exclusion principle and Hunds rule. They will be applied. So I think the things, they are clear to all of you. So the definition, that is very important, and I will meet you in the next video with electronic configuration of different elements. Till then, thank you very much.